All right, students, in this video, we are covering 7.4a, which talks about representing constant rates of change in mathematical and real-world problems. So right here in our first problem here, we have a story about Tommy. It says the graph below shows the number of words in Tommy's essay and the number of minutes he spent writing the essay. Then it asks us which equation best represents y, the total number of words he wrote in x minutes. So let's figure that out. So using what we know, we have this graph here, and this line on the graph tells us that at 1 minute, he wrote this many words, and at 2 minutes, he wrote this many words. At 3 minutes, he wrote that many words, 4 minutes, and so on, okay? But we want to know how much he spent per minute, or given any x, really. But the best way we can set this up is just use our basic rate of change. So right here, I have a nice friendly point. So we know that he did 50 words in 2 minutes. So I'm going to put 50, and because I'm using a trackpad, I'm going to put a W, 50 words over 2 minutes. Whoop. Now, you all know that with unit rate, we are finding the amount per one. Okay, so how much would he write in 1 minute? Well, we would do 50 divided by 2, as we see it there. Another way to write that is 50 divided by 2. And when you do the math on that, you will get 25 words. Because it's not a naked number, we have to put our units. So it's not just 25, but it's 25 words per minute. And I'm going to abbreviate that with W, P, M. So how would I write that in equation form? That the answer is 25 words per minute. Oh, that was ugly. Can I undo that? Let's see. I don't think so. Sorry about that. But how do I write 25 words per minute in equation form? Well, we would put y is equal to 25x, meaning that no matter what x is, we would multiply by 25. If x was 1, we get 25. If x is 2, we'd get 50. If x was 3, we'd have 150. We'd have 75. If x was 4, we'd have 100. If x was 5, we'd have 125. And if x was 6, we'd have 150.